So Java programs are built on small building blocks called expressions. In this chapter, we are going to understand what are expressions, how they work, and how they drive the logic in your code. We'll start by exploring common expressions like the arithmetic, the relational, and the logical expressions, which help us perform calculations, compare values, and make decisions. Then we'll move on to a little advanced area, that is bitwise expressions, the method calls, the type casting, and the use of the instance of operator. And this is something we have looked at in the previous chapter of operators. In this chapter, we will see how expressions are formed using the operators and the variables, the literals, and how Java evaluates them step by step. By the end of this chapter, we'll know how expressions work and how to effectively write clean, concise, and functional code in Java. So let's get into it, shall we? Let's start with what are expressions in Java. In Java, an expression is a combination of variables and operators and a value it is evaluating to. It can consist of a single value, a variable, a combination of variables. The main goal of an expression is to compute different variables using different operators and produce a result. In Java can be as simple as a single literal value, a variable, or something more of a complex operation involving multiple variables and multiple operators. Let's quickly look at different types of expressions in Java. They differ based on their functionality and the type of operations they perform. Let's quickly go through some of the main types of expressions. The first one being the arithmetic expression. They are used to perform mathematical operations between variables using the arithmetic operators. They are going to return a numeric value. So you can perform addition, subtraction, multiplication, division, and modulus. Those are all under the arithmetic expressions. Then comes the relational expressions. These are the expressions you can use to compare two different values. There could be the greater than, the smaller than, the greater than or equal to, the smaller than, the equal to, and the not equal to. The relational expressions are always going to return a Boolean result. That is, the result is either going to be true or false. Then comes the logical expressions. These are used to combine two or more conditions using the logical operators, and they are also going to return a value of Boolean type. That is, the result is either going to be true or false. So these are like logical and, the logical or, and the logical not. Then comes the assignment expressions. These are used to assign a value to a variable. They are used to store a value. These type of expression can also use the compound assignment operators, that is the plus equal to, the minus equal to, the multiply equal to, the divide equal to, those kind of compound assignment operators. And then comes the conditional ternary expression. So this is like a concise way to represent an if-else condition within a single line, a single expression. It evaluates the Boolean expression, which is the first expression, and then it's going to assign the value depending on the condition is true or false. So in this case, this is a condition, and if the value is true, the result is going to be this. If the condition evaluates to false, the result value is going to be this. So that is how ternary expressions work. Then comes the bitwise expressions. Bitwise expressions are used to manipulate the individual bits of a variable. They use the bitwise operators to perform the bit level manipulation on the variable. They are helpful in performing low level operations. The next one is the cast expression. They are used to explicitly convert data of one type into another. So these expressions are necessary whenever you want to change the type of a value from, let's say, from double to int, but you have to be aware that there is going to be certain data loss when you are converting from a higher data type to a lower, in this case from double to int. Then comes the instance of expression. This expression uses the instance of operators to check which class the object belongs to, and the result is going to be either true or false. And this expression is commonly used to check the type compatibility at the runtime. And then we have array access expressions. Arrays are the concept we are going to look at later on, but for now let's just remember that there is something called an array expression. Array is nothing but a list of different values belonging to a specific data type. So to access any particular array element, you can use this array access expression, and the way it works is they use the square bracket and specify the index value of it. Don't worry about it, we'll look at arrays in the later section. Then comes the new object expression. This is a new operator which is used to create a new object for a particular class. This expression invokes the default constructor. Again, don't stress about what exactly is a constructor. We will look at it in a much more detail in its dedicated chapter. But for now, let's just remember there is an operator called new, which is used to create new objects for a particular class. To conclude different types of expression, these are the core building blocks of Java programs, and these allow developers to manipulate data, evaluate conditions, perform arithmetic operations, and much more. Now let's quickly go through the code example. Let's create a class for it, and I'm going to add a main method. Let's get rid of the comments. Let me quickly add some print statements here to discuss different type of expression. We have briefly looked at the code example in the previous chapter discussing the operators. It is pretty much going to be the same. Let's write some simple code to discuss arithmetic expressions. We have created two variables here, a and b. The sum, we have created another variable, sum. So this is an arithmetic expression. We are creating a sum value of a and b. We are creating product of a and b. So let's save the program and run it as a Java application. And here you see the sum of a and b is 8, while the product is 15. So that is working as expected. Similarly, let's quickly go through the relational expressions. So for that, I'm adding these variables here. So int x and 5. These are two variables which we have created. X is greater than 5 here. So we are going to write relational expressions, that is the greater than and the is equal. The relational expressions are always going to return Boolean values. So that is why we are using Boolean variable here. This is going to evaluate this condition. If x is greater than y, this is going to be true, and x equal to y, so this is not true, so this should be technically false. Let's save the program and run. So is x greater than y, that is true. If is x equal to y, that is false. So this is working as expected. And then comes the logical expressions. So logical expressions work on Boolean values. So we have defined two Boolean variables here, condition 1, the condition 2. Condition 1 is set to true, condition 2 is set to false. And then we are performing logical operations on these two conditions. So the logical and the logical or. The way this works is if both are true, then it's going to evaluate to true. If one of them is false, it's going to evaluate to false. That's how AND operator works. And then we have logical OR. If this finds any one condition to be true, the whole logical OR is going to be true. That is how logical OR works. So if we save and run the program and we see the result, so logical AND result is false because one condition is false, and logical OR is true because one condition is true, and that is working as expected here. Let's quickly go through the assignment expression here. So here int c is equal to 10 and c plus equal to 5. So here in this case, it is going to add 5 to c and it is going to store that value again in C. Now technically the value of C should be 15. Let's check that, and here the updated value of C is 15. That is how assignment expressions work. Let's quickly go through the conditional ternary expression. So here int max is equal to A is greater than B. So this is the expression, like this is the conditional expression which it is going to evaluate. If this is true, the max value is set to A. If this is false, max value is set to B. In this case, A is greater than B, so it should evaluate to the A expression. So you see max of A and B is equal to 5. So that is the value of A. Let's quickly go through the bitwise expression just for reference. Again, these are something which work on bit level, so it's a little difficult to understand. So let's not stress much about it right now. This code is just for reference. So this is bitwise AND operation and this is bitwise OR operation. And then we have a cast expression. So to understand how casting works, we have created a double variable called D and we have set its value to 9.8, and then we have created a new variable int value, and we are casting the value of D into the integer. You just specify the casting, you just specify int here in parenthesis, and that is how it's going to convert the double value to the integer value. Save the program and see what is the result. If you see, the value of double was 9.8, and when it is converted to integer, it has lost that 0.8 precision value. You need to be mindful of the data loss you are going to deal with while working with typecasting. And then comes the instance of operator. we can create a simple string variable, hello world, and we can check if this string variable is indeed of the string class by using the Instanceof operator, and it is always going to return a boolean result. So it's going to be either true or false. So you can save that, and if we try checking, it is going to evaluate to true. We are checking it against the class of string, so you're getting it as true. Let's quickly go through the array access expression. This is how you can create an array. We will discuss what arrays are in the upcoming chapter, but this is the simplest form of an array. Array is basically, this is a list of numbers. This is a list of integers 10, 20, 30, and these are placed inside these curly braces. If you want to access the second element of it or the third element of it, you're going to use the array access expression, and you can extract that value. Since this is an integer array, we are extracting it into a different or newly created integer variable or second element, and the array index starts at 0. These are the locations of the array. So it starts with 0. In this case, the 0 element is going to be 10. The first element is going to be 20. That's the reason we have placed 1 as an index here. So this is going to extract that 20 value here, and if we save and run the program, it's going to give us the 20. Let's say if we change the index value to 2, it is going to extract 30. So that is how indexing works in array. Let's say if I put in 0, it is going to extract the first element. Let's revert it back to the index 1. We are getting 20. So that is how array access expressions work. Let's quickly discuss the method call expressions as well. There are predefined methods in Java. So this is a math class, and this is a max method from that class. So this is going to give us a value which is greater than 2. So let's save the program and run. In this, we are passing a and b. So a is greater than b, of course. So it is going to return an integer value, and that should give us 5 because the value of a is equal to 5. And then comes the new object expression. So here we have created a new string. This is going to create a new object of a string class, and it is going to store its value as hello Java. You can save and run the program, and you get the value as hello Java. That is how the expressions work in Java. That is pretty much about the code example discussing how expressions work in Java. Let's quickly go through some of the best practices while working with expressions. Keep expressions simple, don't overcomplicate them, make it as simple as it can. And if the expressions are much more longer and complex, it's always a good practice to break them down into simple, manageable expressions. Use parentheses for clarity when you're working with different operators and operator precedence. You can use parentheses to define which order of operations need to be performed. Use meaningful and descriptive variable names so that you understand what kind of operation and what kind of expression you're working with by just looking at the variable name itself. Be mindful of the integer division. Be mindful of the typecasting. You can encounter data loss while performing these operations. And that pretty much wraps up this chapter. To recap, in this chapter we learned about the expressions in Java. They are something which help us calculate values, compare data, and drive decisions in our code. We covered what expressions are and how Java evaluates them. We covered common expressions such as arithmetic, the logical, the assignment, and the comparison. We also discussed some of the additional expressions such as the ternary, the bitwise, the typecasting, the Instanceof, the array access, the method calls, and the object creation using the new keyword. We also went through a code example to discuss how this works on a practical level. And finally, we discussed some of the best practices and tips you can use while working with expressions. In the next chapter, we'll build on this foundation and see how expressions come together inside control flow and decision making in your Java code. And that's about this chapter. I'm Venkatesh Mudulia. Till I see you again in the next one. Cheers.